we're moving into our next unit that follows scale factor and dilation. So with scale factor, you've learned this in previous years, and the very important skill that you have to know is how to multiply and divide fractions. So we're going to review that, and then you'll have some practice with that. So we're going to start with example A. This is 5/8 times, and we're using the little dot. We get away from using the x because it looks like a variable. You may actually see it as 5/8, and they can be side by side, 1/4. That also means multiply. So we're going to multiply. Now, when multiplying fractions, we don't have to worry about like denominators. We just multiply straight across. So 5 times 1 gives us 5, and 8 times 4 gives us 32. Now, we don't want to change this to a decimal. We want to leave it as a simple fraction, simplified down as far as it can go. So we look, can anything go into 5 and 32 to make it simpler? And it can't. So this is our simple fraction as far as it can go. We can leave fractions improper instead of change them to decimal or mixed number as well, and we'll talk about that as long as they're in simple form. So here's another example. We can multiply straight across, but if we'll notice first, we could actually simplify these down first. So if I look at opposite pieces, like 3 and 9, I can actually cross-reduce these fractions. So I can think about what can go into 3 and also go into 9 evenly. Well, 3 can go into 3 and 3 can go into 9. So 3 can go into 3 one time and 3 can go into 9 3 times. So it changes this problem to be 1/7 times 2/3, and that's the same thing I started with. It's just a reduced fraction. I cross-reduced. Now I would multiply. 1 times 2 gives me 2, and 7 times 3 gives me 21. Then ask myself, can I reduce any further? And I cannot. So my answer is 2/21, or 2/21. Remember, fractions are parts. If I didn't reduce first and I multiplied 3 times 2, I would have 6. And 9 times 7 would give me 63. When I reduce this, I have to think, what am I going to put in to reduce down all these numbers? So I could start with something small like, 3. So I could divide by 3, both parts. 6 divided by 3 is 2. And then 3 can go into 6 2 times and into 3 one time. I would still get the same number, but I had a lot less work to do when I reduced it first. So be aware of that. All right, let's talk about multiplying a fraction by a whole number. Remember, we can make any whole number look like a fraction just by putting it over a 1. So we're still doing the same concept. We still can look and see, can we cross-reduce? Well, 1 and 5 can't cross-reduce. There's nothing to make them smaller. 4 and 8, however, can. So 4 can go into 4 one time. 4 can go into 8 2 times. So what I have now is 1 over 1 times 5 over 2, and I get 5 over 2 when I multiply straight across. 1 times 5 and 1 times 2. 5 halves. Now, I can leave this as an improper fraction. I would rather you do that than changing things around, especially when we're dealing with scale and scale factor, because this is a lot easier to deal with than trying to change it back and forth. Now, if we needed to change it to a mixed number, we ask ourselves, how many times can 2 go into 5? Well, it can go in there 2 whole times. 2 times 2 is 4, and then I had 1 left over. I'd have a half. To change back, I do 2 times 2 gives me 4, plus my 1 gives me 5 over my denominator. So instead of going through all the trouble of changing it, leave it as a simplified improper fraction. It's perfectly fine. If I would not have reduced first, I would have had 4 times 5 is 20, and 8 times 1 is 8, and then I would need to reduce. Yes, it's improper, but it's not in its simplest form. So I could say, well, what could go into both? I could say, well, maybe 4. And if you started with 2 and had to do it a couple times, that's okay. So I'd have 5 halves. I still get the same answer as here, but I had a lot less work to do originally. All right, let's talk about dividing fractions by fractions. So we have a fraction, and it's divided by another fraction. Sometimes we might think about this looking like this. 1/4 divided by 8/3. Looks very crazy. But what this really is the same thing as taking our first fraction, we keep the way it is, and we multiply it by the reciprocal, or the opposite of 8/3, which would be times 3/8. Now we've taken something that looks kind of complicated over here, and we made it very simple. So now we look and we just multiply across. 1 times 3 is 3, 8 times 4 is 32, and we say, can we reduce it? Well, there's nothing that can go into 3 and 32nd the same, so this is our final answer. All right, at E, we have a fraction divided by a whole number. So remember, we can look here. Now, before you start cross-reducing, set yourself up as a multiplication. So we want to set up first 5, 6, we keep. We flip the sign, so we're multiplying by the reciprocal, which is 1/3. Now we see we can't cross-reduce, so make sure you set it up as multiplication before you cross-reduce. Then we multiply straight across, 5 and 18. And then we ask ourselves, can anything go into both of those equally? Well, nothing can go into 5. They can also go into 18 equally. So this is our simplified answer. All right, so now we have a whole number divided by a fraction. Remember, to make it look like a fraction, just put it over a 1. Then let's set up our problem as multiplying by the reciprocal. 8 over 1 times the reciprocal of 3/5 is 5/3. Now, I can't cross-reduce. 8 and 3 can't be simplified any further, and 1 and 5 can't, so just multiply straight across. 5 times 5 is 40, and 3 times 1 is 3. And then ask yourself, can anything go into 40 and 3 to make them simpler? Well, we don't want to change it to a mixed number. We're going to keep it as improper. If you were to put this in your calculator, and you would see you would get a repeating fraction or repeating decimal. So this is as simple as that can go. Okay, as a improper fraction, and that's the way we'll leave it with scale factor. Our last one is we have a mixed number divided by a fraction. So remember, we have to change those mixed numbers first. So the way we do that is we take our denominator, we change colors here, we take our denominator of 3 and we multiply times the whole number, so that's 12, and then we add our numerator. So we have 14 over our original denominator of 3 divided by a half. Now we have a very simple problem, and we just now need to set it up as multiplying by the reciprocal. So 14/3 times the reciprocal of a half is 2 over 1. Now we're going to multiply straight across. 14 times 2 gives us 28 and 3. Now, we've got to ask ourselves, can this simplify any? Is there anything that can go into both? Well, 28 is not divisible by 3 and as a whole number. So this is our simplified improper fraction answer. So you have some practice. Get those skills sharpened back up.